In this video, we present AURORA, a novel data-driven visual subgraph query interface construction framework for a collection of small or medium-sized data graph. The interface consists of 6 panels. Panel 1 allows user to generate useful patterns from the input data graph that supports query formulation and to load previously generated patterns. Panel 2 lists all vertex labels on the data graph. Panel 3 reports the time taken and number of steps required for formulating particular subgraph query. Panel 4 is the query construction panel. Panel 5 and 6 contain the basic and generated patterns of the data graph, respectively. AURORA automatically populates panels 2, 5 and 6. In this demonstration, we show how to generate patterns and to construct visual subgraph query using AURORA with real-world networks. In the first example, we use the PubChem dataset and configure AURORA to generate 10 patterns between sizes 3 and 12. The length of time required for pattern generation depends on the size of the data graph, the number of patterns to generate and the pattern sizes needed. Note that this can be performed offline and the generated patterns are saved in a file that can be loaded when necessary using the Load Local Patterns button. The basic patterns in Panel 5 can be configured to be of different sizes and of different numbers. Here, we set the basic patterns as 3 single-edge patterns. The generated patterns can also be configured to display in different formats such as in a single page, 4 per page, and to be grouped by size. We now demonstrate formulation of the visual subgraph query of an ethyl ester. We shall start by using pattern at a time approach based on the generated patterns and then using edge at a time approach using the vertex label list. The pattern at a time approach took 44 seconds and required 11 steps using 2 generated patterns and a basic pattern. Now we shall construct the query graph using edge at a time approach that is similar to commercial systems like PubChem. In this approach, we construct each vertex and edge at a time. Note that the constructed vertex are not labeled and the corresponding labels have to be assigned later. Observe that the steps in Panel 2 do not account for vertex labeling and it is more than twice the number of steps taken by pattern at a time approach. The edge at a time approach took 1 minute and 11 seconds and required 28 steps. Hence, it is inefficient compared to pattern at a time approach. Now, we shall demonstrate the portability and data-driven nature of AURORA using a different data graph. We now generate 5 instead of 10 patterns for the AIDS dataset. Observe that we use the same interface for this dataset. Panels 2, 5 and 6 are updated accordingly based on the input dataset. Note that the patterns of AIDS is different from that of PubChem. In summary, AURORA provides a common framework to construct the query interface of any source and domain centered on small or medium-sized graphs.